All right, now we want to look at how can we find the equation of the perpendicular bisector of the line that passes through the points C, 2, -1, and 3, 2. So I will start by sketching here that we are going to be having our line which is having points A and B, okay? And then there comes a bisector which is perpendicular, and we know very well if it bisects it will pass through the midpoint of the line AB. Try to bisect any line. Try to drop a perpendicular, and I know you know how to drop a perpendicular, okay? So that means this is our perpendicular line whose equation is required. Are we together? You can call it line 2, and this one you call it line 1. Is that clear? Now, in this case, it simply means we need to apply different methods, different subtopics which we looked at. Okay? So, first of all, we are seeing perpendicular lines, and we know properties of perpendicular lines. Properties of perpendicular lines. Are we together? Now, we know one of the property is M1 times M2 is equal to -1. And we observe M1 will be for line 1. And we can be able, friends, to get M1. And we know very well if we need M1, it will be equal to Y2 minus Y1 over X2 minus X1. Change in Y over change in X. And in this case, we have our point 2, -1, and then we have B, 3, 2. And in this case, we just name them X1, X2, Y1, Y2. Then we do what? We bring these ones and we substitute them here. We say M1 is equal to Y2 is 2 minus -1. A minus is here, and this minus is for this one. Is that one clear? So over 3 minus 2. And then we proceed down and we say this one will give us a plus. So we have 2 plus 1 giving us a 3 over a 1. That means our M1 is equal to 3, friends. And this 3 is for line 1. Now, friends, what we do is we look for M2. That means M2 is for that perpendicular line. So we know our property very well is M1 times M2 equaling to -1. Our M1 is 3 times M2 equaling to -1. Hope we are following. So I divide by 3 throughout. Therefore, my M2 is equal to -1 over 3. Now, that means I have the gradient for the perpendicular line, that bisector. Are we together? Now, I observe very well from up here, this point that I have and this point that I have, they do not lie along the perpendicular bisector. And you can see it's here and here. You cannot use it to find the equation of the perpendicular bisector. Is that unclear? Now, what you do is you ask yourself, where does this perpendicular pass? We say perpendicular line passes the midpoint of the line AB. I say, okay, that means I need to look for the midpoint of the line AB, and which would be now a point that will be shared by two lines, the perpendicular and the line AB. And therefore, I will use my gradient, -1/3, and then the point which I have calculated. Very simple. Now, the way how we get the midpoint of AB, okay? And I can call it capital M, which is going to be given by just the average of those two. y1 is y2 over 2. That one clear? Now, and I named my things already. Therefore, I come here and say my my x1 was 2 and my y2 was 3 over 2, comma. Then my y1 is -1 plus a 2 over 2. And therefore, I come up with my midpoint as 5 over 2. And then, sorry, this is -1 plus 2. That is giving us 1 over 2. And therefore, our midpoint is 5 over 2 and a half, which can be written as 2.5 and 0.5. But let us use this one. Therefore, now we have our gradient and a point. It's a very interesting number. You have a gradient and a point. This point is the only point that lies on this line. The rest, they are not lying there. You can see with your eyes, this point is not on this line, and this point is not on this line. It is only the midpoint, and which you can use to be able to get the gradient. And now you know very well our general equation of the line, mx plus a c, okay? Y is equal to mx plus a c is the general, where this is the y coordinate, the gradient, the x coordinate, and the y intercept. We already have our gradient. We substitute it there, x plus a c. So the only thing remaining is to find the c. Therefore, the way how I can find the c is very simple. I come, I say this is my x coordinate, my y coordinate, and are the same things that I'm going to be substituting in this case so that I get the y intercept. Hope you're following very well. Therefore, my y is a half equaling to 1 over 3 times my x coordinate, which is 5 over 2 plus a c. Very simple. This one will give me a half equaling to -1 times 5 will give me this over 6 plus a c. So this guy, I bring him this side. Therefore, I have this one plus 5 over 6, giving me a c. Because it's a negative, when it crosses the equal signs, it becomes a positive. Therefore, here when I look down, I see 6 is my LCM. So 6 divided by 2 is 3. 3 times 1 is 3. Plus 6 divided by 6 is 1 times 5 is 5, which is giving me 8 over 6. By 2, 4. By 2, 3. Therefore, my c is equal to 4 over 3. And therefore, you come and conclude this one, the c, which you have gotten, should be substituted back in your equation. Is that one clear? Most people forget to substitute. Follow my arrows very well. Therefore, I will say y is equal to -1/3 x plus the intercept, which is 4 over 3. Now, this is what has been making us sweat. And you observe when you get this gradient, m2 is equal to -1/3, and the gradient m1, which was a 3, if you multiply the two, they have to give you -1. 3 times -1/3. Okay? Here once, here once. We come up with a -1. So friends, thank you for watching. I remain Huntington, your math teacher. Thank you. Mama.